Hi everyone, Abhi again. Have you noticed how traffic lights have nuanced differences with roundabouts? Well, roundabouts are inherently trust-based systems, so if the drivers do not follow the right of the way, there is no roundabout, there's just a traffic jam, right? Whereas traffic lights actually take that trust out of the system by instituting a signaling system, and then the only people who we have to trust to follow that are at the front of the queue. If they don't follow, there is a T-bone collision, right? Statistically speaking, roundabouts are incredibly more safe. They keep the traffic flowing, cause less frustration, so they're better all around. Of course, they're trust-based systems. They don't work in all scenarios, especially when the volume is too much or the people are unruly. Then obviously they don't work. But in most places, they're incredible. The same dynamic is also applicable to the workplace. So you have seen this. If you've been working long enough, you are probably lucky, like me, to have worked in a command and control structure, and you've also worked in a trust-based system. And the outcomes matter, right? We are very subjective beings, and we're miserable in a fear-based environment, and then we are typically thriving in a trust-based environment. And I know that it also differs a lot on the people in question. But I've been thinking about whether this dynamic is also applicable to agentic systems for a few days, and there was only one way to find out. Have a look at this. That's right. What you just saw was basically a trust-based agentic system led by Mario the Great, and in his team are Luigi and Toad, and then Donkey Kong is the fearsome leader, and he's leading Dixie and Diddy, and they've all solved like a bunch of problems together. And in this case, well, of course, the trust seems to have won. But is it so simple? Let's talk a little bit about the experiment, right? So the experiment is to check if the fear-based or the trust-based agentic systems differ in performance. So we will be testing three hypotheses. Number one is, the accuracy matters depending on the persona of the leader. Remember that the people working are neutral, so they are not different in team A versus team B. Hypothesis two is that they differ by model, because not all agentic systems are made alike. And then hypothesis three was, well, does the, especially in open source systems, do the newer models are more compliant, or do they differ vis-a-vis the older models, because the architectures are so different, right? Nowadays, everybody is doing MOE kind of models, and previously we used to have dense kind of models. So I just wanted to test that out as well. So this is what the experiment is. So when I ran it for the first time in the run that you saw, this speed run, what you saw was like there are 20 problem statements, okay, and they're divided into like 5 categories. There is maths, there is coding tasks, there is logic related tasks, so things like taking a goat and a wolf and a farmer from one end of the river to the other end. And then there is also like constraint, and there is extraction. So constraint meaning counting hours in a strawberry, right? It's not a very it's a sequential kind of a thing, which the LLMs are particularly not good at. We all know this. So imagine like 5 problems each. And the first findings when I ran the experiment like that you just saw, it was incredible. So what we noticed, again, the models in question were Nemotron by NVIDIA, Alibaba's Quen 30B, a very nice model, Kimi K2, again, this took the world by storm. When it launched, DeepSeek, of course, we've all heard of DeepSeek, and the latest entrant in the Chinese ecosystem is the GLM5, incredible model. In this experiment, you will see some statistics, and the OG of the world, Claude Sonnet 4.5, and then OpenAI's own open source model, GPT OSS 20B. Initially, when I ran the 20-something test, I wasn't testing all of these models, as you will see in the results, but then later on, I included them. So, as I said, the first result was that there was some effect, okay? So the smaller models appeared to be helped by fear. So the fear produced a 5% better outcome, but that's like on a sample size of 20, that's like hardly anything. And it seemed to have hurt the larger models. Again, this didn't make any sense, but like a tiering hypothesis was formed, like, okay, tier 1 models, tier 2 models, and tier 3 models, and how they differ. And the only thing that was left to do was then maybe increase the sample size. So I scaled the question bank, so to speak, from 20 questions all the way to 220 questions. And similar categories, again, no difference. And I had to actually work through quite a few technical challenges, despite Claude code, the agentic harness and the way the extractions, the parsing errors and the API errors, and getting all of these models to work through a custom LLM router was not trivial. So it took me a few days. But after scaling, the results actually blew the hypothesis out of the water, right? So the little difference that we saw at sample size of 20 completely was obliterated at the sample size of 220, or for every model there were like 440 runs, one set per team. And there was no meaningful persona-driven accuracy difference, except for Nemotron appeared to favor the trust a little bit, but I don't think that difference was statistically significant. One thing we did see was, because the fear-based system is more prescriptive and it causes a bit of longer chains, and therefore it had a higher cost, higher number of tokens, higher time spent, and accordingly, sometimes because of the longer chains, there were errors. So this was a verdict, and the thing that stood out was that hypothesis 2, which is the size of the model vis-a-vis the accuracy, actually did matter. And there was one exception which we'll talk about, but the smallest model with 3 billion active parameters did not do very well. Kimi K2 was an exception, but like otherwise it was directly correlated to the number of active parameters. As you can see here, we had Nemotron with the lowest accuracy, followed by DeepSeek, followed by GLM5, and then GPT-OSS in its own right was an exception. But we'll see about these two exceptions, like why did we have these two exceptions. So I tried to kind of reason with it, did a bit of research, and this is my first time running this kind of a benchmark. So if I'm committing some scientific blasphemy, please bear with me. So in Kimi K2 apparently uses a different kind of sparse parameter ratio. So it's got 48:1 sparsity. So out of 384 experts that it has, only 8 are active at any given time. So it's optimized for breadth rather than depth, and that has an effect on the quality of the reasoning. But this benchmark is all about depth, right? It has a lesser number of attention heads vis-a-vis DeepSeek, for instance. And then GLM is also trained on a lot more. So GLM has the lowest sparsity ratio. It's 19:1 over 48:1 of Kimi. And then the training corpus is like almost twice. So obviously GLM has performed better. But that's not all, right? I mean, GLM was also trained with far more modern architectures. It is trained with DeepSeek's sparsity attention architecture. And then there was GPT-OSS, the OG. This model really surprised me. And when I did a bit of research, I found out that this model was distilled from O3 and O4, which is like 100 times more. And I'm sure OpenAI has a very sophisticated post-training, with reinforcement learning, maybe RLVR, and they also have a very, very good quality of architecture that really works for them, because this new harmony format really makes sure that the reasoning chains are always right, like every single time. There was no parsing errors on this model. So this model really surprised me. And it is also like 6:1, so the lowest sparsity ratio. So at any given point in time, more parameters are active, and therefore that seems to be helping as well. But the parameter size is like only like 21 billion or something. Finally, this is not a surprise at all. The hypothesis 3 recent models are doing better. As I said to you, scalable RL including RLVR, the DeepSeek sparse attention introduction in GLM5, and then a better training data set, and then instruction following tuning. With all of the newer models are doing, the open source is getting really, really amazing. Last but not the least, I think that one thing is seen very, very consistently is that regardless of whether a model is from the frontier labs and a closed model or the open model, they all struggled on constraint, like counting the R's in a strawberry kind of problems. The next category was logic, and they all struggled on that a little bit, not a lot, but inherently signifying the pattern matching nature of LLMs, like showing that there is no true novel ability to come up with new patterns. I think this is at least my hypothesis, but definitely constraint satisfaction seems to be the most purest measure of raw power. And then to summarize, I think it was a really fun thing to do. I will share with you the repo and all of the presentation that I've been showing you over here. The human analogy fails every single time. So we should be really wary of anthropomorphizing these models. Did I say that correctly? I don't know. There is really important to experiment, because there is so much complexity. There is mixture of experts. There is active parameters. There is overall parameters. There is training corpus. There is some bunch of post-training optimizations, and these days people are applying pre-training optimizations around reinforcement learning. So that seems to be having an effect as well. And that open source system is just going north. And even though Claude Sonnet still beat GLM5, which is the latest model, I would think that GLM5 is an incredible model based on what we've seen. But GPT-OSS 20 billion is also an incredible model. Like, it is for the size and what you can do in an open source environment. That model really surprised me. So especially with a lot of focus nowadays on sovereign AI, we need to be embracing open source as good as we are utilizing these frontier models. And this was just a fun experiment I wanted to share with you. I hope you enjoyed that. Feel free to let me know how wrong I was on many of these things. And I hope you have a cracking week ahead. Take care.